Say be like me, Miller. What? What we're going to learn today? Teach me how to do it. Teach me how to do it. Hey, teach me how to do it. Teach me how to do it. All the cool kids know how to do it. Hey, all the cool kids do it. My name is Miss Miller. I'm going to teach the kids today how to find out if an exponential function is a growth or decay. All right, sit back, relax, stay, and we're going to learn. All right, what's up, you guys? I do not own the rights to that beat or that music at all, but I do want to have fun with you guys. We're going to learn about exponential functions. I love exponential functions. Y'all know I just about say I love everything dealing with mathematics. I do. All right, so to get started, we've learned about linear functions and quadratic functions. The third function in this 9th grade GSE curriculum is exponential functions. All right, and it is y equals a times b to the x. Yes. All right, you guys should be familiar with y equals mx plus b. Not only did I teach you this, your 8th grade teachers taught you this as well. And you know that this is a linear function. Every degree or every exponent is 1. Well, this is the only, the only degree is 1 to our independent variable. You learned that x was our independent variable, y is our dependent variable. Same thing here. Independent variable, dependent variable. The only thing that's different than b in a linear function is our y-intercept, but it's not that in an exponential function. So don't get those two confused. That's a big misconception. So we're not going to confuse the two. In fact, we're going to know this so well, y'all going to be making up y'all own rap. I want someone to spit a rhyme better than mine. I thought I would say that. All right, I lost my little eraser. It's okay, y'all know I erase with my hands. Okay, so let's go ahead and get started. A equals our starting value. Our starting value is also known, sorry about that. My tablet is not acting right. I normally record with my phone. A is our starting value. Another name for starting value is called y-intercept. Y-intercept is our starting value, initial value. You have various names that we've called it, but it all means the same. Just know the meaning of it is the starting value. What did we start out with? We started out, I'm going to show you examples. Tomorrow we'll talk more about word problems, but I want you just to get a conceptual understanding that A is our starting value. It's almost the same as our B and y equals mx plus b because it's the y-intercept. And we know when we find our y-intercept, our x always has to equal to what, guys? 0 on our graph. So when we talk about y-intercept, we're talking specifically about a graph. But when we're not looking at graphs and we're looking at equations or when we're looking at word problems, we still need to be able to identify it. So you can say initial value, starting value, y-intercept. But usually the y-intercept refers back to our graph. So, but the starting value, initial value, would be our A. Remember, the A is the first letter of the alphabet, guys, so it started out with A. Alpha is our alpha. Alpha is the beginning. All right, so just remember A is our starting value, what we start out with. All right, and B is our growth or decay factor. What we're going to learn today? We're going to learn whether the exponential function is a growth or a decay. All right. So that's our essential question. Is an exponential function a growth or a decay, or how to identify an exponential function as a growth or decay? Our learning target as well is to learn whether an exponential function is a growth, learn about exponential functions, and whether they are a growth or a decay. All right, all right. So, I didn't know if I was recording or not. I'm not used to recording on my tablet, but it's kind of cool. I hope this comes out larger than my phone. But it keeps sliding. My phone doesn't slide. All right, so to get started, I'm going to give you guys some examples. This I can use my glove. All right, so the examples will start out with y equals 5 times 2 to the x. Let's identify our A and our B, because this function only has an A and a B. That's our independent and dependent variable. independent, dependent. We know what those are already. We just need to have a better understanding of our A and our B. So to do so, yeah, I got smaller, I got shorter, guys. All right, our A equals to 5. What's another name for that A? The starting value, the initial value, or we also know it as the y-intercept. Okay, so let's talk about our B. Our B is equal to 2. That's right in front of that exponent. The number in front of that exponent is always your growth or decay rate. So since 2 is in front of that exponent, 2 would be our growth rate. A good example of a word problem, I started out with $5. It doubled every day for 10 days. How much money would I have? That's, I want you to think about that. So if it's doubling, that means it's growing exponentially. If it's growing by 2 every day, it's growing every day by 2. I didn't say that word. Y'all know sometimes I get tongue-tied, but it's okay. So it's growing by multiplying by 2 every day. Okay, so now that we know that it's multiplying by 2 every day. So this is a growth, guys. Is B greater than 1? Is 2 greater than 1? Of course it is. Okay, a kindergartner would know that. So let's just go to the next one. Well, most of them would know it. So I don't want to make this complicated. I just want to explain it as best I know how. 3 times 7 to the x. All right, A would equal 3. B would equal to 7. All right, is 7 greater than 1? So if B is greater than 1 and B is 7, is B greater than 1? Most definitely. So that is a growth. I'm going to give you an example that is not so concrete and a big misconception. So let's start off again. Let's say y equals 3/4 times 10 to the x. All right, let's talk about our A and B. Can y'all see that fraction? I know some of y'all freeze up when y'all see these fractions. Let's change it to a decimal real quick. So I want you to understand the concept. All right, A equals 0.75. Is it the same thing as 3/4? When I tried to put that 3/4 and I didn't write it real cute, so I wrote it as a decimal. And the decimal's not cute either. All right, there we go. It's legible. Y'all know what I mean when I say cute. All right, and B is equal to 10. All right, question for you guys. Is my B greater than 1? Of course it is. Even though that A is less than 1, that doesn't matter. That's just the starting value. It's going to start out with 3/4 of 0.75, however you like to see it. So if you get confused with them fractions, change it to a decimal real quick. Some of you should be able to do on your own, but some of you need a calculator to do it. So I don't want to confuse you guys with the concept by throwing a fraction in. Next one I'm going to give you is, my eraser went bye-bye. I'll figure it out. Y equals 100 times 20 to this. Ooh, that's growing real fast. That's how I want my bank account to grow, guys. All right, start out with $100. Every day or every month, it was 20 times as much. I take a month, because a day I would be filthy rich. All right, so this is growing because our A is 100. Start out with 100, and our B is 20. Is B greater than 1? Of course it is. All right, I'm going to give you another example that's a misconception, a huge misconception. All right, Y equals 3x. All right, what's my A, guys? Miss Miller, what is the A? All right, the A is always a number that stands alone. So y-intercept. It cannot be in front of that exponent. So let me just give you a hint. The B is 3. It's tripling. This is tripling. Something that's tripling would have this. They say the rabbit population is tripling. I think this thing we're going on now is tripling. Because it's an exponential growth. It's not growing linearly. It's not a linear growth. It's not growing by a constant rate, so it's not linear. I think it's growing exponentially. Sometimes I get tongue-tied on that word, guys. Don't judge me. All right, but it is an exponential growth. All right, so if it's tripling, it grows 3 times every day. All right. Now, A would be our starting value. When we don't see a number in mathematics, or we don't see a number in front of a number, it's always understood to be 1. Let me tell you why. So a 1 is there, but we don't write it started out with 1. We can just write it like that. But a 1, so our A would be 1. If A cannot equal to 0. All right? It cannot equal to 0. Why? Because it would not be an exponential function. It would not grow or decay if A was equal to 0. So A can never, ever, that's not a word, so don't quote me on that, but it can never equal to 0. So A can never equal to 0. So just make a note of that. So it has to be, it could be 1. It could be less than 1. But it can never equal to 0, guys. Our B can never equal 1. So let's talk about B can never equal to 1. Why do y'all think B can never equal to 1? Let's talk about powers of 1. What's 1 to the first power? 1. What's 1 to the third power? 1. What's 1 to the 100th power? 1. Only thing that's different, not even 1 to the 0. 1 to the 0 is what? 1. All right. So let's just know it. 1 to any power will always equal to 1. So that's why it can never equal to 1. B cannot equal 1 and A can't equal 0. Think about it. 0. A can't equal to 0. B can't equal to 1. A comes first in the alphabet. B comes second. 0 comes before 1. All right? So just think about that. A can never equal to 0 and B can never equal to 1. So let's talk about, so our A will have to be 1. Our B is 3. So this is a growth, most definitely, because B, again, is greater than 1. Let's talk about a decay. I'm so excited. Y equals 5 times 3/4 to the x. Is this a growth or decay? This is definitely a decay. Because A equals to 5 and B equals to 3/4. All right, one more example. I miss you guys because normally you help me make up these examples. And we were in our group chat today. We did something a little different. So I want you guys to help me because you really, sometimes I can't think to make up examples. But we have Y equals to 100 times 4/5 to the x. And Y equals 100 times 3/5 to the x. Which one is decaying faster? That's a trick question for you to think about. Which one is losing its value faster? Quick example of decay. Guys, how many of you know when you drive that nice car off the lot, brand new, brand spanking new, it depreciates in value. Meaning depreciate means it loses a lot of value usually. Most cars do. Now, not all cars. Some cars hold a value, but it depends on really, most cars do. So, they could grow, they will, it will hold, this one holds 80% of its value. This one holds 60% of its value. So let's just change these to decimals. Which one is holding more of its original value? So this one's decaying at 20%, while this one is decaying at 40%. So I'll get into that, guys, when we start talking about these word problems. I love these word problems. You know why? Because they're real life. A lot of you ask me, when are we ever going to use this? Yesterday, I showed my mom the video, the last video I did. She asked me that. She said, Shauna, when will anyone ever use this in life? And I had to think about it. I had to explain to my mom, well, we're going to use the quadratic formula when you're trying to find the zeros. And it actually teaches critical thinking skills. So my mom asked that because, I don't know why, but I like showing my videos to my mom. And some people even say older people and other people that I show it to that's not in this math class, so they really know how to do it now. So I'm excited. I hope this helped you guys. If you have any questions, please feel free to hit me up or group me. If you need a private session, hit me up. I also put on our on my site, I also put a Quizlet that I would like to take. If you want to challenge me, you can. Or if you want to spit a beat to challenge me, you can. I'll be here, guys. I'm staying in the house and being safe. I want you to do the same. Be safe. Wash your hands. Say quarantine to yourself. Do not be out in public. And peace.